very much. So APIs in the fast lane. I actually want to start off with a question. You call an API and you get a 400 error response. You've checked the docs, but it's still broken. As a room full of engineers, who's ever been in this situation before, where you think it should work and it hasn't, and the docs aren't quite right? See a couple of hands, yeah. It'll be a few more of these questions, and I can just make out the hands, and we'll see how that goes. So what if we had a tool that was able to generate all of our client SDKs, all of our documentation, and some of our server-side interfaces or implementations for us without us having to remember to update anything manually ourselves in different places? Another show of hands, who's ever forgot to update the docs when they've made a change before? Everyone's hand this time, I think. Yeah, exactly. So my name's Ryan Cormack. I'm a principal engineer at Motorway. We're an online used car auction marketplace and an AWS community builder. There's some fast facts about Motorway where I work, where our online auction marketplace does a bunch of things across the UK. But I think one of the most interesting or really powerful facts that we've got is that as a business, there's over £2.5 billion worth of car sales, vehicle sales, goes through our platform every year. And that's a really, really important number, firstly because it's a really, really big number, and it's a growing number, but because cars tend to be a really valuable asset that a lot of people own, as a business, we want to make sure that despite us being really, really high value and comparatively low volume compared to some e-commerce companies, every one of these car sales counts, and every one of these car sales for our customers is impactful. So when we have situations where our documentation and our SDKs and our servers don't all line up, there's real-world impact that can be measured in sometimes up to thousands and thousands of pounds. So it's really critical that we're able to nail some of these pieces. So the next half an hour or so, I'm going to talk about the different ways, all the front doors that we've got when we're building things like APIs on AWS. A little bit about some of the ways and the domains that we may want to be building our systems and architecting our systems in. I want to talk a little bit about a tool called Smithy, a tool that might help us solve that question that I posed at the start, making sure that we're able to build everything in a consistent, reliable way. How we're starting to look at using Smithy in that software development lifecycle at Motorway, some of the benefits that we're getting from it, and how some of the teams are finding it as we're rolling it out. And then, last point, speak a little bit about beyond building RESTful APIs, and maybe some of the other ways that Smithy could help us in the future go beyond these traditional RESTful APIs that we're thinking about. So back to that headline point again. You call an API and you get 400. You've checked the docs and it's still broken. And I think part of the reason this can happen is there's so many different ways to start exposing systems and services and APIs on AWS. All of them are unique and all of them are good in their own different way, but there are a lot of them. And this is just some of them here. We've got things like Cloudfront that can be used to start to route traffic as it comes into your system. But primarily, it's a cache and a content delivery network, allowing you to get close to your customers where you need to. It isn't necessarily a dedicated API gateway. We've got application load balancers. These can be public on the internet, and I'm sure people are exposing their ALBs on the internet and then routing traffic to their individual services as they need. Another really, really popular option. And then finally, there is API Gateway. API Gateway, when I say API Gateway here, I'm thinking of the more traditional REST API gateways rather than the HTTP API gateways. But fundamentally, they're solving the same problem as an actual API gateway with a bunch of API gateway features for you to allow it to expose your services. They're able to deal with things like API keys, authentication keys, authorization management, caching, rate limiting, some of the things that you do expect from an API gateway product. So just a quick couple of visualizations for some of these things. And as I look through these, I think you maybe start to see, maybe resonate with some of the different ways that you or your teams are building some of these APIs, and just the different ways that people could access your systems in different ways that highlights some of this inconsistency that you can sometimes get. And because we tend to find lots of different moving parts that have to be updated, that we do find some of these things drifting from what we would like. So Cloudfront, like I said, can route traffic to API Gateway or to load balancers. I think typically the API Gateway and the load balancer are also publicly addressable on the internet in so many systems and setups, which gives us that different way of accessing the systems that may have slightly different behavior. Got multiple Lambda functions. We've heard already today a lot of times of people building serverless systems. We do a lot of that too, but really, really nice, powerful, and interesting. But you end up with quite often multiple different API gateways all exposing these individual systems and services, not necessarily one-to-one Lambda functions. An API gateway might expose a whole bunch of them. But again, it's another example of having so many different front doors tends to lead towards this inconsistent approach for how you might document your systems and how the client SDKs and things might present themselves for internal teams and third-party teams. Got a single load balancer. This one's actually looks really, really simple, but just exposing the load balancer like that removes a lot of the API gateway benefits that you get. And I think typically you might find yourself having to run your own API gateway tooling behind the scenes on this, which again brings in that inconsistency. I suspect most people's primary job function at their business isn't building API gateways, so we want to make sure that we're leaning into using as many of these managed services as we can to do all that undifferentiated heavy lifting for us. So all of these different front doors lead to this scattered entry points. There's different ways to access your system. You might have to deal with different authentication methods across different types of products, different ways to expose your documentation, which I think is a really, really important point. Sometimes we're missing WAF, an application load balancers, logs, things like that. If you have 20 different API gateways from 20 different teams deploying these things, it can sometimes be really, really hard to enforce that consistency and approach of securing them with WAFs. So make sure that all the logs are shipped off to the correct place, in the correct format, in a consistent way, doing consistent request validation, things like that. So we can consolidate all of these things together and just have a single API gateway that's able to expose a whole bunch of either different services or one service that might fan out into different applications within that single domain or that single bounded context. Got our Lambda functions here, API gateway can route to those. API gateway, REST API gateways anyway can route to Fargate and ECS tasks if you want. You've got to deal with some of the overhead of managing network load balancers and application load balancers and things like that. But it is possible to start to standardize all around a single API gateway. We've got our single WAF up at the top there. We can have a single cache if we want to in front of all of this. And it pushes all of these teams together to build things in this single entry point or this single exposed fashion, allowing us to have a slightly more consistent API footprint, slightly more consistent way of doing documentation, slightly more consistent way of doing rate limiting, request throttling, access control, all these sorts of things. And then, yeah, it comes with a whole bunch of benefits here, and I think the driven consistency of all of this together starts to make this really, really easy for internal teams to start consuming, and I think more importantly for a lot of people, third-party teams, external teams to start consuming. Earlier on this morning, we heard a lot about from Luke of how that the complexity and the control that you've got over other team systems and services could always have an impact or a trade-off on how it is that you're building things. So it's really, really important to make sure that when we aren't in control of all of these API consumers, we're giving them the best possible, most consistent, most reliable experience possible. So how would we go about building it? I think if we're thinking about a traditional RESTful API in this case, we might be wanting to build all of our systems inside domains. Those domains give us that really, really nice consistent interface that we're able to expose to third parties. To actually make the requests on specific entities or resources, we want to make sure that we're having consistent operations. In this case, I'm thinking of things like, for motorways context, if we're selling a car, you might want to add a photo to that vehicle profile so you're able to understand a bit about it. You may want to place a bid if you're wanting to buy the car. If you're selling your car online, we want to make sure that you're able to confirm that sale. And because all of these different processes happen on primarily clients that we control, mobile applications, web applications, we want to make sure that it's still consistent and easy for these different teams to consume in a well-expected way. And that's where this consistency really, really helps drive home the ease of development here. And this ends up with nice-ish, possibly here, RESTful-looking resources that we're able to expose onto all of our clients. And because we're thinking about all of this in a consistent cross-team way, we're able to start to think about how we continue to control this, deploy this, and provide this experience for all of our users. And this is where a tool like Smithy can really, really help and come into play here. So just a quick show of hands. Has anyone heard of or used Smithy before? Yeah, quite a few hands actually, more than I was maybe expecting, but really, really nice to see. I suspect for everyone else, may not have heard of it, but I suspect most people here, if you're running any sort of workload on AWS, you are probably using it. So Smithy is an interface definition language. It's actually an open source tool originally developed internally at AWS and then publicly released it. It's quite old now, maybe 6, 7, 8 years. But I think it's at the point now where almost all of AWS services are firstly defined in Smithy And they rely on Smithy to then do a lot of this heavy lifting to keep this consistency in the server implementation, the client SDKs, and the documentation, amongst other things, all up to date at the same time. So I mentioned Smithy is an interface definition language, and it is very much that. Smithy helps you define your interfaces, and it's very, very opinionated about defining the interface, and doesn't matter at all how you want to think about that implementation. Again, earlier this morning, we saw this example of having these really, really thin, well-defined interfaces exposing this deep, the deep implementation detail behind the scenes. That a lot of this complexity sort of concept here, that we want these interfaces to be strong and well-defined, and Smithy, being an interface definition language, helps us define these interfaces. Smithy is also a CLI tool. So we can define our interface, and then we're able to then use the CLI tool to start to generate the documentation for us. It will then automatically co-generate a lot of the client SDKs for us. It will generate server-side interfaces for us too, that we have to program against, where our implementation lives, but it ensures that interface that's exposed is the same interface in the documentation, the same interface that our client SDKs use, and the same interface that we're programming against on the server to help keep that strong consistency everywhere. And Smithy has a couple of key concepts, really only two core concepts to it, the idea of a shape and the idea of a trait. So shapes in Smithy. A shape can be anything from a service, a resource, or an operation. If I'm thinking about a motorway, a service here might be a vehicle service, or it might be an auction service. The system that is, or the bounded context that's able to process and operate on a bunch of resources. And again, a resource in Smithy is just another shape. In this case, a shape here, or a resource, might be a car. A car might have a license plate as an identifier. It might have a number of doors. It'll have a make, a model, a mileage, things like that on it. And then Smithy has also got this concept of an operation. An operation, in this particular instance, might be a get operation. You might do an HTTP GET request on a vehicle, and it will return a car. All different shapes in Smithy that we're able to define in this language. And then Smithy's got traits. Traits are just ways to add additional context to a shape. So if people are familiar with languages like TypeScript, C#, Java, Python, traits can be applied to a Smithy shape with, as a decorator, and you're able to add these decorators to your shapes to give that additional context. And it might be to state the fact that your shape is going to be an HTTP RESTful resource. It might be some documentation, or it might be a custom trait for some internal information that you might need to help you with your deployment pipeline. You can even add things like HTTP bindings or authentication traits to these services defined in Smithy, because it's going to help you define that public interface for how your service is going to work, and then you can then concentrate on all of your implementation detail yourself. So I'll take a quick look here about how you could go about using Smithy to kind of tie these concepts and traits and shapes together, and try to emphasize why doing this becomes really, really powerful, because it's not tied to a language, it's not tied to an implementation detail. We've got an example here of a simple car service. So I mentioned before, we might have a service that is the vehicle. A vehicle service has a version on it if we want, but a vehicle service exposes resources. A resource could be a car. Down at the bottom, we've got the car shape getting defined here, and this identifier is getting marked as a VRM, or the license plate, registration plate for a vehicle. And we can see here that the VRM is actually typed, and then we've got the read operation that you have on this car resource. So we're defining the fact that a user, anything, is able to do a get operation on this car, and it will return the get car shape. And here we can see that get car shape. The get car is a shape, but it is defined as an operation. We're actually adding a couple of traits up at the top there to say that this is an HTTP method. It's a get method, and we've got the URI for it. We're also defining it as read-only. And I think typically we think about RESTful services doing HTTP GETs, it would be read-only anyway, but we're explicitly marking it so here. And we're defining the type of error that it's got. We can a no such resource or a 404. Got a couple more shapes to look at. We've got the input. So the input for this is the VRM, and we can see here that we start to see our first find trait. We've got this pattern trait. It's getting decorated over the VRM type, And it's actually it's a regular expression that is that's defined there for what a UK license plate might look like. And we're defining all of this in Smithy. And whilst we've written some interface definition language code here, we haven't actually written any of our implementation detail at this point, but we have defined everything that we need about our interface so other team systems and services can start to understand how this application might work. And because we defined all of this now in Smithy, we don't have to go about doing any of that implementation detail for us to start socializing these contracts, these interfaces internally. We can start to build stub endpoints against it if we want. So we're able to then start to build out this decoupled modular approach to building our systems and services, where the client team might be able to get started because we've got the interface that they'll be working against already defined. So we can use the Smithy CLI to start building all of this examples together. And I mentioned earlier that we can use it to generate our documentation. Because this is going to be an HTTP service, we might want to use something like OpenAPI, really common specification on how we define and share and expose HTTP API contracts internally and externally. And we use the Smithy CLI to do that. Really, really easy. It's actually only 4 lines of JSON there. To define the Smithy build object, we run the Smithy build CLI command, and we're able to get a whole bunch of information out. And to do that with the HTTP Open API specification that we want, we're defining another trait. We've got a trait here on line 8, REST JSON1, and that's just to tell Smithy that when you run this, we want to make sure that you're going to build an API specification from this service that we've defined. And we've got that trait to say that it was an HTTP GET operation, the trait to say that it's a RESTful JSON API, and Smithy takes care of the rest for us. So we just run Smithy build. Really, really easy CLI command. There's not much that can go wrong with it. And out the back of it, it defines our Open API specification for us. I'm using an open source tool here called Redocly to visualize that API spec, but we have the whole API spec, complete with all of those traits, the documentation marks and things like that we've added for it, and it's automatically updated this for us. I'm not sure if you can see it, but up at the top, we've got the path parameters part. It's defined as a VRM. It's mentioned that it's required, and it's got that regular expression built into it there. So Smithy's helped us define the request validation that we would want to have applied at our API gateway. It's helped us define and build that Open API specification for us. In just a second, we'll see the server-side code that it's helped us define. So we've seen an example of it code-generating the Open API specification for us, allowing our teams to now work and build independently from each other. We can then discuss and we can review these API specifications if we need to, but we can also get started building the client SDKs if we need, or the server-side implementations of all of this code if we want to. And it's important to note here that Smithy just isn't a tool for building RESTful APIs. It's a tool for defining your interfaces, whether they're synchronous, asynchronous. Out the box, it's able to build protobuf definitions from this IDL if you need to. And it's in many ways language agnostic. It's able to build client-side SDKs for around 10 languages and server-side interfaces for a whole bunch more. And that allows us in a multi-language organization to have a very consistent way of defining all of these interfaces across teams. Any team can have a look at someone else's Smithy specification and understand what it's going to do without having to know the ins and outs, the details of a Nest TypeScript API or a Python Flask API. And it gets our server bindings now for us. So all of the interfaces that are defined here are all interfaces that Smithy has automatically generated in TypeScript for us based off of that interface that we've got. So up at the top on line 1, we're importing this vehicle service interface, and we've got to then implement it. So out the box, it's an interface, and it tells us that we've got to implement that get car operation that we defined in Smithy. So Smithy is not opinionated about how you define your implementation. It's only opinionated about making sure that you expose your interfaces to people. What you want to do now with this implementation detail is completely up to you. So we're just implementing this get car on line 5, this get car by VRM method that we might have here. That can go off and call a database, anything else that we need it to do. But it makes sure that we're either returning a no such resource exception or error, or we're going to be returning the strongly typed car information object that we defined in Smithy. And because this is now in a typed language, the things that we've defined in our interface in the Smithy language is the same thing that's defined in our Open API specification. It's the same thing that our compiler is going to make us return from our TypeScript implementation, and it's the same thing that gets defined in that client SDK. There is no room for error here, and it will not go wrong because it's all getting built from exactly the same source. And here's a quick example. Again, it's not opinionated about where it is that you run your code. I think we heard earlier today again that we may want to start running this on a Lambda function to massively reduce the operational overhead that we've got. So this is an example on line 10, us running this in a Lambda function. But there's nothing stopping us just taking this, the vehicle service interface that Smithy has generated, and us then going and running that in a container on ECS if you want to, inside an Express application, sorts of things like that. And of course, there's nothing stopping us writing or building our code in this pattern anyway. In fact, I think it's it works very, very well with this hexagonal architecture approach. But by doing this, it gives us this strongly typed interface that we must always adhere to in all of our server-side code, allowing us to really easily port it between different compute runtimes should we ever want to in the future. So spoke a little bit there about the Smithy language itself, maybe how you could go about using it to start to define your systems and your applications. How might we pull this together internally at Motorway right now? So first of all, it's really, really important that for all of these contracts that either work between teams or that we're going to be publicly exposing to third parties, it's really, really important that we define that interface. And we want that interface to go through a review process and ideally happen before anyone has to start writing any of the implementation code, so we can change it as early on in the life cycle as possible. So by defining everything in Smithy, it means that we're able to get that consistent interface defined very, very easily, whether or not the teams will be writing TypeScript, Python, or any other language. Once we start to understand what's going on, the development can start. And because Smithy has already code-generated the client-side SDKs for us, the documentation for us, and the server-side interfaces for us, it means that our web team can get started, or our Android or iOS teams can get started building how they would start consuming these new services. And of course, our Smithy schema gets deployed. And we can actually use other AWS services like the EventBridge schema registry to store all of these schema documents. We can collate all of these together using events out of EventBridge and then build that consistent API documentation in a single place with them all collated together as that one public footprint that we might have. And then, of course, the service goes live. And then any time that we change this in the future, because we'll be changing the Smithy definition first, we know that the server-side SDK, the client will get updated and the documentation will just get updated all together. So hopefully this means that we never get into this situation where someone's trying to use one of our APIs, they're using our client SDK, they've read the documentation, but the servers return something a little bit different. We should hopefully want to trend towards a world where this can no longer happen because they're all kept consistent with each other. So we might still have a whole bunch of different front doors, and I want to speak a little bit about how you might move and consolidate all of these front doors into a single entry point, and then gradually over time start to make sure that everything becomes more and more consistent. We've got maybe a custom API gateway. It might be sitting behind a load balancer that's exposed on the internet, and then we've got a couple of API gateways exposing different Lambda functions or services behind them. So we can maybe start to think about using AWS accounts as this bounded context, or this construct that keeps this isolation boundary really, really nice and small, allowing our teams to work independently of each other. But we still need some way to start moving the traffic over from maybe our legacy APIs that we've found to be inconsistent over time to our new very consistent way of building. And we can use Lambda Edge to help us do that, or Cloudfront Functions. Something really, really lightweight that sits right at the edge that takes these incoming requests, intercepts them, and decides, is this one of these new consistent APIs? If it is, start to send the traffic over to our new API gateway if we need to. And then over time, we see more and more and more services be migrated over to this new way of building and designing our APIs. So what if we had a tool to generate the server-side code, the client SDKs, and our documentation all at once? I think we do, and I know, conscious that Smithy might not be the only one of these that is available. It's shares a lot of similarities with things like GraphQL, but it does allow us to get that strong consistency across the whole development lifecycle of all of our APIs, making sure that our public and our internal contracts are always kept consistent, kept up to date, and kept and reviewed in a consistent way across the organization. And then finally, I want to touch a little bit on looking beyond RESTful APIs. So I think I spoke a lot there about how we can use this to build REST APIs, and I mentioned that Smithy can also generate your protobuf schemas if you're using RPC or gRPC systems. But Smithy could go a lot further than this in the future because it's not opinionated about your implementation, it's just opinionated about that interface that you're exposing. And I think, certainly in 2025, and probably going a lot further beyond that, RESTful APIs might not be the only sort of interface that we're exposing with other systems and services. It feels like we're moving quickly towards a world where MCP servers or AI agents are becoming a new way that we expose some of the internal functionality of how systems work. And Amazon Bedrock Agent Core, it was a mouthful. Amazon Bedrock Agent Core is just another service from AWS that starts to allow us to expose these agentic systems and services, either internally within your company or to third parties if you need to. And one of the really interesting things about this is that Smithy's becoming almost a first-class citizen on Bedrock Agent Core, allowing us to define our MCP or our agent tools in Smithy. And that, I think that generates a really, really interesting point where we could start using Smithy to expose our RESTful APIs where we need to, but it also means that we can start exposing agent tools, again, defined in the same interface definition language, keeping the documentation up to date for all of this, but it allows us to then concentrate on the implementation detail however it is that we need to, and we can connect now these MCP tools to different systems and services internally, and we don't have to generate these as RESTful APIs. We don't have to generate OpenAPI specs for the MCP tools, and we can start to differentiate these. Or we could have a single service. The single service could have a REST decorator over some operations, and it could have, in the future, an MCP tool decorator over other services for us. Smithy will generate all of these server-side interfaces and allow us to even use Agent Bedrock Core to expose some of these MCP tools internally to agents or externally if we need to. That sounds like a really, really great, nice future of where we would like to get to, but this stuff's really, really hot off the press, and I don't think it's currently quite there, but I'm really, really excited about the direction that these sorts of things are going, and it's nice to see like the ecosystem all play really, really well with each other. Unfortunately, for now anyway, the list of unsupported features with Smithy on Bedrock Core isn't quite as long as the list, or that's not true. The unsupported list is slightly longer than the list of supported features today, but this is a screenshot from last week, and it's probably already changed, and it's moving really, really quickly. So I'm really looking forward to seeing how we can use one interface definition language to expose our systems and services in different ways that allow us to keep up with this agentic future that we're looking at in quite a lot of places. So yeah, it'll be really, really interesting to see how this one plays out in the future. Just want to have a quick recap here. So we've looked at different ways of exposing APIs on AWS, some of the pros and cons of doing it. Occasionally it can let teams move really, really quickly, but you sometimes sacrifice that consistency of operational security with your WAFs, of observability with your inconsistent log definitions, and possibly the lack of consistent documentation that you may have. And then taking a quick look at Smithy, the open source tool from AWS that allows you to define your interfaces in a very strongly consistent, opinionated way, but allows you to develop your implementation detail in a very unopinionated way, however you want to do it. It doesn't care about how you implement these services. It just helps you define that interface between all your systems and services. Smithy can do all of that code generation for you to help you do your server-side things, your documentation, your protobufs if you need to, a whole bunch of different things. And because it's extensible, you can start to write your own traits to extend the different things that Smithy can do. Maybe you've got specific metrics that you want to keep a lookout for on your API gateway. Smithy can help you code generate these things and then share those traits across the organization. And it makes it really, really easy to plug into Lambda. There's a whole bunch of different things that Smithy can do that make running on Lambda and API Gateway really, really easily. But again, because it doesn't care so much about the implementation detail, it would allow you to then transfer that onto any different runtime compute that you need to in the future. So I've got a couple of QR codes here. One's to the Smithy language homepage. One's to, I've got a GitHub repo just showing a really, really small example of what a car service or a vehicle service might look defined on Smithy. Slightly different to some of the other examples that Smithy language has got itself. So yeah, please grab them if you'd like to have a look. And yeah, finally, I'd like to say thank you very much. If you've got any questions, I think I've got time to have some now. And a couple of the QR codes. Connect with me if you want to ask anything afterwards on LinkedIn, or I'll certainly be around for the next rest of the evening.
Wonderful. Round of applause, please, for Ryan. Who's first for a question? Yep, I'm on my way. Keep your hand up, please. There we go.
Hi. So thanks. That was a really good talk. Really interesting idea. I'm very strongly considering pushing for the more use of Smithy, say, the company I'm working for. One thing that we have a problem with and is often a concern, and I don't think it got covered here, is validation of types and type guarding coming in, effectively matching schemas of incoming requests. So if you've got the open API spec, you have the types defined, that's great, but how do I know actually that what I've received matches those? Or is there a way to generate a validator, or do I have to then maintain that separately?
So I think I heard most of that. The question was, how do we make sure that the incoming requests consistently validated against what our server is expecting, things like that. Is that right? Yeah. So
yeah, and can we generate those automatically as part of the Smithy build command?
Exactly, so you can. So with some of the traits for API Gateway, Smithy will automatically generate the Open API spec for you, but it will also generate the Open API spec with the REST API Gateway AWS extensions and the validators that you need for that. So it can help you use API Gateway to validate those incoming HTTP requests at the gateway with that validator built from exactly the same definition of Smithy definition that you've got that then gets passed into your code.
Right.
So if you're using API Gateway, you could do it like that. But equally, if you're using Python, Express, any other server-side language yourself without API Gateway, because you've got the guaranteed consistent Open API spec too, you could use something like Express Open API Validator to make sure that you validate it now inside your own application logic too, rather than on the gateway, and you get that consistent input validation. With output response validation, so you won't get the response validation going out through API Gateway, but you've still got the return types in the Open API spec that you could validate internally inside your code if you wanted.
Okay, yeah, so it's effectively there's a third-party integration that you're hoping to rely on, whatever it is.
Yeah, third party in the sense that one's an AWS open source tool and the other one's an AWS API Gateway tool. I guess Express is third party there, yeah.
All right, thank you.
Okay, who's next with a question? Okay, Aled, hello.
Hi. If we're starting with an Open API spec because we're using API Gateway, how do we then start adopting using Smithy? Yeah, so if you've got your pre-existing Open API spec, maybe you've handwritten it, maybe you've generated it from some TypeScript type, something like that. I think there's a way that you can take an Open API spec and convert that back to your Smithy language, and then from that point on going forward, I think I would try and rely on updating the Smithy model first, and then pushing everything forward from that. Pushing it into API Gateway, we use Terraform to deploy all of our APIs for us, and the REST API Gateway has got an import API definition method on it. So we take the API Gateway specification that Smithy's generated for us and apply that against the API Gateway to make sure that the API Gateway now stays up to date and consistent with the Smithy definition, and then the server-side code that we built from that. For a lot of the other systems and services,
I think it's just a long method. A little bit there, I spoke about how we start to move some of these systems over from an old, I'm going to call it a legacy service, into something a bit more modern. And we use Lambda Edge or Cloudfront Functions to do that, basically just on URL path matching. Anytime we've built a new URL or a new system in a slightly more modern way, we'll add it to our Edge router system, so it'll start to shift traffic over one route at a time for us, one HTTP verb at a time.
Okay, we're at the afternoon break now, so if anyone wants to go, feel free. But equally, if anyone else has got a question for Ryan. Yep, great. You happy with this, Ryan?
Yeah, please, yeah. I'll be around all afternoon too. Love to chat more.
Thanks, Ryan. That was really interesting. Just a quick question around where maybe you might be using more native AWS connectivity for asynchronous, so SNS, for example, to connect things together. You mentioned about event bridge schemas as well. Is there anything else beyond the event bridge schemas that you shared there that Smithy can do when it comes to more native integrations for things like SNS, where you might be using that as a mechanism?
So out the box, not that I'm aware of with a direct native integration. I guess because, like I mentioned, we use Terraform to deploy our API gateways, and Smithy isn't necessarily opinionated about how you deploy your services and systems either. It's not super opinionated about the transports that you might use, SNS, SQS, things like that. That said, I showed the example of it generating open API specifications. We use EventBridge for a lot of our internal communication, and whilst we don't do it quite this way, we actually use Event Catalog that David spoke about earlier to do a lot of our async stuff. We could use Smithy again to define the shapes, the resources that we've got, and then generate a JSON schema object for EventBridge communication if we want to do things over EventBridge. SNS, I don't think has JSON schema, I guess, validation or anything like that in it, but you could still generate the payload shape in JSON schema and validate that before you'd send it over SNS.
Okay, so that is an output format that you can get. You can get to JSON schema.
There is a JSON schema, yeah, trait somewhere in there, yeah.
Brilliant. Thanks, Ryan.
All right, and if anybody else wants to ask Ryan a question, he's a very open and friendly chap and is here till closing time.
All night.
Thank you. Right, another round of applause, please, for Ryan.
Thank you very much.